Here's problem 9.11. A 3 kilogram mass is released from rest at point A of a circular frictionless track. A radius 0.4 meters as shown in the figure. The mass slides down the track and collides with a 1.4 kilogram mass that is initially at rest on a horizontal frictionless surface. If the masses stick together, what is their speed after the collision? So this is really two problems in one. We have conservation of energy from point A to point B, and then we're going to have the collision where we'll have conservation of momentum. Our mass 1 is 3 kilograms. Our mass 2 is 1.4 kilograms. And our first task is to figure out what is the velocity of mass 1 right before the collision. So we're looking at a height here. It's going to start from rest, go down that height without friction to a lower height, and hence its velocity, v1 initial, is going to be equal to the square root of 2gh. Just from conservation of energy, that's going to be 2 times 9.8 times 0.4 meters for h, square root, and that's equal to 2.8 meters per second. So that is the velocity of mass 1 right before it hits. So now we have a new situation. We have these two carts, mass 1 and mass 2, and mass 1 is moving with a v1 initial of 2.8 meters per second. v2 initial is 0 because mass 2 is at rest, and then they're going to stick together, and we want to find what's going to happen afterwards when they stick together. So they have one common final velocity. So we have the one equation to rule them all for momentum, which is mass 1 v1 initial plus mass 2 v2 initial is equal to mass 1 v1 final plus mass 2 v2 final. But in this case, v2 initial is 0 because we're at rest, and final velocity for both of them are going to be the same because they're going to stick together. So I have mass 1 v1 initial equals mass 1 plus mass 2 v final. And so, solving for v final, we have v final is equal to mass 1 v1 initial over mass 1 plus mass 2. That's going to be equal to 3 times 2.8 over 3 plus 1.4. And that's equal to 1.91 meters per second. So that is the final velocity of the two carts after they stick together in an inelastic collision, 1.91 meters per second.